All right, everybody, thank you for your time again. Today, we are going to go over tips and tricks for scanning different types of project sites, job sites, and the different trades that would be scanning. My name is Andy Huntley. I'm the Scanning Technology National Sales Manager for TopCon Positioning. I've been doing some kind of positioning work for over 10 years. Um, Last company I worked for, I was in charge of their scanning department and also ran the research and development. While doing the whole 10 years of some kind of positioning experiences, I've got to introduce different technologies to different customers, such as GPS, robotic and manual total stations, 2D, 3D machine control, laser scanning, and drones. So, like I said, today we are going to talk about scanning. At TopCon, we have a few different types of sensors out there that does scanning, but our two main focuses we're going to do is going to be on the GTL and the GLS 2000, just because these two units are more widely recognized. So our agenda, what we're going to go over is the different types of projects and how to approach them. We're going to go over survey projects, dirt projects, concrete, MEP, and wall contractors. So let's talk about survey projects. How does scanning help a surveyor? Well, it complements their existing topo data. It allows for basically the surveyor to go in and scan everything just in case he misses something. And it allows for them to add extra points if need to be. So with having this technology, surveyors can benefit being able to, one, only have to send their crews out once and be done. And then two, they're able to reach harder places. As an example here, this bridge, I don't have to have a man lift to put a guy up in a basket to shoot tops of those man lift or bridge points. So these are some of the big benefits. Now let's look at how I would approach if I was going to do a topo with scanning. Here is our project site. This is a commercial piece of property not too far from where I live that, as you can tell, Google Images is kind of behind times. There's already several businesses already established. But when it comes to surveying, the surveyors need to go in and do a topo of the site so that the designers and developers know exactly how to put the buildings and sidewalks, easements, things like that. So what I would do if I was out here is I would come in and set my instrument up right here in the bottom. I would go set it up, do a quick scan, and then go start shooting some points. I'd shoot like back of curbs and your gutter lines, your center of road, any fire hydrants, things like that that you normally do. Then I would move to another location and scan again. And I would keep repeating the process so that while I'm collecting my topo data, I'm also scanning my site so that I can get a full 3D image of what's going on. And then once I have all of that, then I can sit there and send it to the architects, the point cloud, which they would probably end up loving because nowadays they like to work in 3D environments. And they can start developing where like this Panda Express is going to be sitting. And so that's some of the benefits for surveying. And using the GTL, it's one instrument that's going out there versus the two, where traditionally you would have a scanner and a total station. Next, dirt projects. Dirt projects, you must use control points to tie the scans together. And I will tell you that because for scanners to work with cloud to cloud, you had to have vertical structures for it to do its overlappage. Well, on these dirt projects, if I set my instrument up on a known point and I reference back to another known point, I can easily tie all my scans together just off of that. And now my scan data is accurate and clean. The dirt guys would love this technology because it allows them to complete a thorough as-built of their site to check to see where their cut and some fills are how much more they need to start cutting. Do we need to fill up more just to help with the balancing of the land? And typically for these, you need a lot more setups because of the way scanners work. Scanners have a hard time capturing the ground below because of the angle of attack. So what I would do on a dirt project is I would just set up my instrument throughout. I would look at the way the land is, and I would set up at the top of an embankment, at the bottom of the embankment, a couple of times on a building site pad like this. And I would just move my scanner from point to point until I have a good coverage. And like I said, all of these points I would want to tie into actual job site controls, especially so that I can do the volumetrics reports to see I'm at. Concrete. Concrete can be very difficult, like I said, due to the way scanners work. Scanners collects beautiful data on features that are vertical or your ceilings because it's capturing lots of points on those. Now on the ground, it's a little different because of, like I just said, the angle of attack. If you go too far out, your laser light pulse will hit the slab, ricochet, and bounce off. That's any scanner out there. So you have to do more setups. And then with concrete, there's different things you've got that you're trying to scan for, and you need to know these. If I'm scanning for the walls, or my columns to make sure they're right, I can be quick and easy with that. But if I'm trying to scan for a FFFL report, I need to make sure I have good, clean data and enough data to overlap it. The next thing is you need to know what are your specs going in for the FFFL, because if you've got something that's got really high specs, you need to know, can my scanner actually do it? And I will tell you, my rule of thumb for scanning has always been, if it is a really, really high FF number, you're going to want to do as many scans as possible with it. And you're going to want to document exactly where every one of those scans are, just because you're with an FFFL of a 100 over 75, you're splitting hairs, and that's how tight your scans have to be. The other thing is scanning can also help your concrete contractors save money. They're always about, how can I protect myself? So if I was to go, and this was my project, and I was told, hey, I need to go scan this site for FFFL, or I need to scan it to do like a beam camber analysis, I would take it and look at where my columns are and treat them like bays, and go every other bay I have a scan. And I would just leapfrog across the building until I felt like I had enough clean data to show that, hey, I've got everything I need. That is the biggest thing, is when it comes to scanning, I'm always going to stress, if you think you got enough, do 2 more scans. Now, MEP contractors. I'm going to merge the mechanical, the electrical, and the plumbers together, just because a lot of times they all tie into these big, huge rooms. And like you see in this photo, there is a ton of things going on in here. These are really difficult to scan because you see how busy they are. And when we want to scan them, we want to see every pipe. We want to see where every valve is, things like that. And so these require the most amount of scans for the smallest rooms you could think of. Traditionally, scanners, we want just a few scans in a room. These, we want a ton. And if I'm going to do like a cloud-to-cloud registration, I'm going to have a 50% overlappage. And so with the MEP contractors, we want a game plan. We want to go in and know, what are we focusing on? How detailed do we need it? What are we putting our data into? So here's an MEP room. Like I said, they are beyond busy, as you can tell from this CAD file here. But if I was to approach it, I'd start up my scanner on a known point, and I would just move down a few feet, maybe 10, and I'd just work. Every time I'd set up a new station, and I'd just keep leapfrogging all the way through until I felt like I had enough clean data on all of it. So like I said, this small room, you've got 13 or 11 scan setups, where traditionally in an empty room like this, I would probably put maybe 4. And that's the thing when it comes to MEP contractors. You want to make sure you have the most amount of data possible. Wall contractors. Sometimes these are the easiest scan projects to do because they just want to make sure the walls are in the right spot. And so you can set the instrument up in the middle of the room and scan, and these walls being vertical, you're going to get a ton of points onto them. So you'll know exactly where they are. And it's easy for the scanners to hit these. So, like I was saying, if I was to go walk into a hotel lobby and the engineering service called me and said, hey, I need this scan because we want to remodel this hotel, I would start very entry. I would scan, and I would just work my way. I would do a lot of scans kind of closer up where the busier traffic is. And so if you notice, I have 3 scans piled up right there, right at the front. And then I have my 4th scan down in the hotel lobby bar. And I would just move my way around, but not focusing too heavily in certain areas until I have everything perfectly laid out. And that is how I would approach if I was going to a sheetrock guy or a architectural firm that needs to just know the dimensions of the building or the house. It's something just like this. So, what is the key? Well, since we are in football season, we're going to treat it like we're playing a game here. We need a game plan. When we go out, we need to know, what are we scanning? What are we looking for? Who's the data going to be for? If we wanted to sit there like this photo here, be the marching band, we need to know exactly where we're going to be stepping, or that T could easily turn out to look like an X very quickly. So always go in prepared. Next, know what your end results need to be. Know if I need to put my data into Verity, I need to make sure I have good, clean coverage on those mechanical pipes, so that Verity can easily register and give us a good, clean, accurate report back. And the biggest thing I'm always going to stress is, if you can, always process your data on site. This will allow to make sure that you have every scan station you possibly need, and you've got every coverage you need before you leave. Because the biggest headache you'll always have is, I need a little more over here, and so now I had to drive all the way across town to go get that just one scan. When I'm there already, I spend 30 minutes and process my data, and I see I got enough. So with all of that, I think there was a question in the chat. Concrete project, Bill asked, concrete projects as you described them here, not a good case for the GTL, should use the GLS. Concrete in the GTL is a phenomenal tool. Reason I say that is, you can easily tie all your point clouds directly to the actual job site controls that the concrete guys are working on. Now, the GTO, I will say, can do everything a concrete contractor wants. I will use caution on the FFFL. We are still in the process of getting that fully validated to make sure it can match exactly up to a dipstick. But everything else, without a drop or a beat, it will definitely do it. I actually have a couple of concrete customers that are using this instrument right now. So if you'd like to know more, Bill, please reach out. I'll definitely help you on that. Any other questions? Okay. Well, with that, I would like to say thank you guys for your time. If you have any questions or think of anything, please reach out to your Topcon Sokia representative, and we'd be more than glad to assist you. Other than that, you guys have a good day, and we'll talk to you guys later. Thank you.